So, good afternoon, ma'am. So, I am JR Mikutuan from this MT2 section methodologies. So, in this video, I'm going to explain the first step rule. So, first step rule, given a function of f of x, the definition of first derivative, the derivative of f of x is lim h over h approach 0 f of x plus h minus f of x over h, provided the limit exists. So first step rule, write f of x plus h and f of x. Compute f of x plus h minus f of h. Combine like terms. If h is a common factor terms, factor the expression by removing the common factor h. Simplify or simply f of x f of x plus h minus f of x over h. As h approaches 0, we must cancel the 0 factor into h in the denominator in step 3, and then compute lim approach over h approaches 0 by f of x plus h minus f of x over h by letting h approach 0 in a simplified expression. So this is the example 1. So we have a given of f of x equals ax squared plus bx plus c. So this is the solution in step 1. F of x plus h equals parenthesis of a times a x plus h squared plus b times x plus h plus c, and then f of x, this is a given, f of x equals ax squared plus bx plus c. And step 2, f of x plus h minus f of x equals a times x plus h squared plus bx plus h plus c minus ax squared plus bx plus c. So this is a step 2. So simplify, add or minus. So we have a times ax squared x squared plus 2xh plus h squared plus bx plus bh plus c minus ax squared minus bx plus c. So we have in total of, we have ax squared plus 2axh plus ah2 plus bx plus bh plus c minus ax squared minus bx minus c. So cancel out the same with the same number with different like minus or sum. Like we have a sum of ax2 minus ax2 equals 0, and other is the bx minus bx equals 0, c is minus c is 0. So we have only 2axh plus ah2 plus bh, but we have the same common, so we need to get the same common later. So we have h, so let's put it out, the h, and then create a parenthesis, create a and then 2a plus ah plus b. So that was the correct answer. So in step 3, f of x plus h minus f of x over h equals the answer of the step 2. So we have h times 2ax plus ah plus b over h. So cancel out all, cancel out the h in outside of the parentheses, so cancel out. So we have only 2ax plus ah plus b. So in step 4, h is approaches 0, so we need to swap the h into 0. So we have only one h, so 2ax plus ah plus b, so equals 2ax plus a times 0 plus b. So we have only a times 0 is 0. So 2ax plus b. So that was the 4-step rule. And constant rule. Then we have the constant, that was the 4-step rule. So the second is we have to discuss the basic rule of differentiation. The first is the basic rule. So the derivative of a constant. So let's see be any constant, then its derivative is just like d over dx constant equals 0. So example of letter A, ry is 5. So but the first is it was dy over dx. So let's put it out the y, because y is a constant. So y is like c, a constant. So d over dx y is equals to 5. So we need to get the 5 in right, just like this formation, formula. And then 5 is a constant, so it was only constant to, it will be if c is a constant, it equals to 0, just like this. See, 5 is constant, so it will be 0 because it was constant. And then number 2, the derivative of a power, let n be a non-zero constant. Ano man? Oh. And then we have example. So y equals x cubed. So dy, so the solution is dy over dx equals d over dx x cubed. And then this is the solution. So our non-zero, let n, so our constant is not to be 0, so it was n, so n and constant, and then n, let's see like this, n x n minus 1 gets non-zero. We're going to put an n to the constant x, so n x raised to the power of 3 minus 1. So our n is our n is 3. This the non-zero constant, so 3. So we have n x n minus 1, so our n is 3, so we put 3x raised to the power of 3 minus 1. So we have the answer of 3x squared, because our n will be subtract into 1, so it become squared or 2. So this is the answer. So then derivative of a constant multiple. So let's see be any constant and f of x be any function. So d over dx constant times f of x equals constant d over d of x and f of x. So we have example of y equals 5x squared. So dy over dx equals to d over dx times multiply to 5x squared. So equals 5 constant 5 and then d over dx multiple to x squared. So our u or y will be f of x be any function. So let's see be any constant. So our d over dx is our n. It is our n of our x. So if our n is squared or 2, our d of x will be 2. So 5 times 2 x, our n is 2 minus 1. So we have answer of dy over dx is equals to 10x. And then the sum of and difference rules. So given the functions of f of x and g of x, the derivative of their sum and difference is defined by d over dx f of x positive negative g of x is equals to d over d of dx times f of x positive negative d of x d over dx g of x. So our e is I have example of y equals to 2 x cube root is 4 minus 3x. So dy is equals dy over dx equals 2 our derivative of the sum is difference be defined. So given the function of f of x and g of x, so our f of x is 2x4 and our g of x is 3x. So our f of x will be simplified by putting the n to the f or before the x, just like this, nx, just like this before, and ito nx raised to the power of n minus 1. So mo repunin na hitabo. So 2 times 4 x raised to the power of 4 minus 1 minus 3 times 1. So 1x is equals to 1. So 1, so if x will be, we're going to use 1 raised to the power of 1 and then minus into 1. So this is, so we have a total of 8x cube x cube or 3x3 minus 3x raised to the power of 0. But x raised to the power of 0 is equals to 1. So we're going to swap into 1 dash or simplify or what, hindi ko alam. Basta ganon, gawing 1 natin. So 8x3 or cube minus 3 times 1. So we have a total of d of x over dx equals 8x squared cube minus 3. And then this is the example. So we have a product and quotient. So our product rule of differentiation. So let u and v be function of x. So we have functions of d over dx. uv is equals to u times d over dx times v plus v times d over dx times u. So we have a u of, for example, this example of a. So we have y equals 3 times cube times minus 2 times 2x plus 5. So we have a u of 3x cubed minus 2 and our v is 2x5 plus 5. So we're going to simplify. So equals 3. So u times d over dxv. So our u is 3x cubed minus 2. So let's put the u and then times the d of x and then the v. Our v is 2x plus 5 and then plus our v. Our v is 2 plus 5 times d over dx and then multiply to u. So our u is 3x cubed minus 2 and then the total is 3x cubed minus 2 and then we're going to substitute the n of the constant like 2 and then the x and the x is have a 1 n. So it minus 1. So 1 minus 1. So 2 times 1 x plus 1 and then 5 will be going to, because 5 is constant. Any constant will be going into 0 without x. Constant x. Non-zero is x. Non-zero is x. But numbers, any other numbers or any single numbers will be constant. Even if either the number have x, it was non-zero, constant. But 5 is only a number, so magiging constant. So magiging 0. So plus 2x plus 5. So simplify and then substitute the n. So 3 times 3 x raised to the power of 3 minus 1 and then constant of 2 is 0, so minus 0 and then total of 3x cubed minus 2 and then 2x 0. 2x 0. But 2x 0 is, diba, x over x raised to the power of 0 is 1. So mahimong 2 na siya. So may mo na siyang 2. Di na 2x 0. 2 na siya. And then plus 2x plus 5 times 9x squared. And then ano yung x and then n times n plus 1. And then the total of 6x cubed plus minus 4 plus 18x cubed plus 45x squared. And then add them and then we have add the same same x squared muna. Add na sila. Sila same na x, like x squared or x cube is add na sila. So atong i-add ang ang same ra ni kay 6 ug si 18 man. So mo na nato ra atong add. So atong i-add sila may mong 24x cube plus 45x squared minus 4. So this is the answer. And then the quotient rule of differentiation. So let u and v be function of x. So d over dx times u over v equals v times d dx over dx times u minus u times d over dx times v over v squared. Parang lisod-lisod na. So y, we have example of y minus 5 over 3 of x plus 4. So our u is 5 and our v is 3x plus 4. So we have solution. So dy minus dx equals to 3x plus 4 times d of x, d over dx times 5 minus 5 times d over dx 3x plus 4 over 3x plus 4 squared. And then simplify. So we're going to cancel out the 3 times 4 in times 0 plus 4 plus times 0 because 0 naman na sila. Wala naman na. Ilan naman 3x plus 4 na times mo 0. Wala. 0 gyapon. So cancel out na siya. And then ang may bilin is minus 5 times 3 times 1. So mo gyapon ikuha na to ang n. So times 1 kay kung unsa ang n sa x mo po na n ikuha sa constant na number. Mo na siya ipares. So 3 times 1 na x raised to the power of 1 minus 1 plus constant of 4 is 0. And then over 3 plus 4 squared. And then the total of negative 5 times 3 and then times 1 over 3x plus 4 squared. And then we have equals to negative 5 times 3 over 3x plus 4 squared. And then solve. So we have a total of dy over dx equals to negative 15 over 3x plus 4 squared. So we have a chain rule. Chain rule differentiation is given a composite function y equals f times g of x. We let the inner function g of x equals u. Then the derivative of u of y minus equals f of u is given by dy over dx equals dy over du times du over dy. So we have example of y minus 3x plus 1 times raised to the power of 8. And then now, so our u is 3x plus 1 and our y is u8. u8. D of x, timan ini. D over d of x times x raised to the power of n equals n x raised to the power of n minus 1. And then if x raised to the power of 0, it equals into 1. So dy over dx equals d over du times u raised to the power of 8 times d over dx times our u, the 3x plus 1. And then equals 8u raised to the power of 8 minus 1 times 3 times 1 x raised to the power of 1 minus 1 plus 0 because 1 is a constant. And then substitute, and then we'll be going to 0. And then we have a total of 8u raised to the power of 7, 3 times 3. So, we need to multiply the constant 8 to the 3. So, we have a total of 24u7. And then, what is our u? Our u is 3x plus 1. So, our answer is dy over dx equals 24 times 3x plus 1 raised to the power of 7. So, that's how chain rule. So, high derivatives. So, the one half derivative is the first derivative. The two, like ng kuwit, duha ka kuan is second derivative, and then third, and the fourth, and then so on. So we have an example of, we have a function, f of x of, so our example is, find the fourth derivative of the function. So, pingtaon na nato. So, we have a f of x equals x over x raised to the power of 5 minus 3x raised to the power of 4 plus 2x cubed minus 2x squared plus 4x minus 10. So, our first derivative of x is 5. So, the solution is 5. So, di ba, n, x is a non-zero. May mo na siyang non-zero kung ang n sa x is butangan po, ang n sa x is i-multiply po sa, or himuong constant sa x. Murag ibutang sa ubos, murag i-times po siya, i-times siya. Mo nang, di ba, times 5 siya. Times 5, di ba? So, mahamin mo na 5 times x. Di ba? 5, 5. So, bawasan ito isa, mayroong 4. So, ang kanang isa is 5 na siya. So, ito na i-times sa x. So, mayroong 5x 4. Raised to the power 4. And then, ang 3, i-times mo na to sa raised to the power of 4. And then, 12. And then, maminusan po 1 ang x raised to the power of 4 minus 1, so 3. So mura nag mag-minus muna kada unsay kuan sa x nday 2, and then imong constant is 5. So karang 2 may mo na siyang i-multiply na sa constant na 5. So may mo ng 10, and then di ba ang x di ba 5x squared man na. So, mahitabo na, may mong 10x na lang. Kay, ang 2, minus naman pong 1. So, may mo na lang pong 1. Kung may mong 1, ang mahitabo na, x na lang na siya. Adi naman na siya. Duha. Isa naman na. So, muna x na lang siya. So, may mo siyang 10x. Mura na, 10x. Mura na. So, ang ato pa itaw na is fourth man. So, ato na siyang i-times siya. So, 20 times 5 times 4, and this 20 times 3 is 60 times 2 equals 120. So, our fourth derivative is 120, and then 12x cubed, so 36x squared, and then 72x, and then ikaupat is may mo ng 72. Mawa naman kay x is equals to 1. And then, minus 1 pa sa minus 1, and then, may mo sang 0. And then, ang 6 minus x squared, ato na siyang gamiton, and then, i-times siya, and then, 6 times 2, 12. And then, x naman na bilhin, isa naman, so, ang x is 1, so, i-minus mo na to, 1 minus 1 is mo na 12 na lang. So, ang 2x, isa naman na. So, inig-minus na 2x, 1 minus 1 is equals to 2. And then, wala naman, constant naman siya mo na 0. Tapos, kanang 4 is a constant. And then, may muna siyang equal 0. So 0 na siya. So kanang mga constant na di pa kaabot sa ikakuan, may muna siyang 0. 0 na siya ka. And then kung may muna sa 0, 1 na siya pulos, mawala na. Antod sa ikaupat na derivative. And then that was the end. So our last is the integral. So this is how the integral. This is how the integral answer. And then number 2. So we have an integral of 4x dx. So equals the integral of 4x dx is equals to 4 integral x dx, and equals to 4 times, may mo na siyang times, and then x is only 1, di sa x squared. Kaya kung x squared pa na to, x is 1, and then sa integral is dili pareha sa derivative na minus 1. Integral is plus 1. So x raised to the power of 1 na plus 1 over the dx is 1 plus 1, and then the total of 4 times x squared over 2, and then we have the total of 4x squared over 2. So this is how the integral solve. And that's all, ma'am. So sorry kung mura o makati ang tingo, ma'am, kagisip on jud ko, ma'am. So that's all, ma'am. Thank you.